Today we're looking at two different things, the segment addition postulate and what is a segment bisector. So your essential question, how do I apply the segment addition postulate and bisect a segment? Your learning intention, I'm learning to perform segment addition and construct segment bisectors. You've got actually three. The first warm-up question is, what are the three undefined terms in geometry? And then find the midpoint and distance, or the length, of this segment. So pause the video and see if you can do that now. If you don't remember, get your notes out from last time and you'll find the three undefined terms in it. So, what are the three undefined terms? Do you remember? Point, line, and plane. Now, to find the midpoint or the length of a segment, you need to know the endpoints. So the first thing you will always do is find those endpoints. The point is -4, -1. This point is 5, 3. Now, substitution for my midpoint. x1 plus x2. So that will be 5 plus -4 or -4 plus 5. Divided by 2. Now your y values. 3 plus -1 divided by 2, or -1 plus 3 divided by 2. Remember, whichever point you start with, you need to start with the x's from the same and y's from the same point. So 5 plus -4 is 1. 1 divided by 2 is simply 1/2. 3 plus -1 is 2. 2 divided by 2 is 1. So your midpoint where y is 1, this would be, then x will be 1/2. And that'll be your midpoint. So it's going to be, here's your y value, this is 0, this be right in there. Any questions? So it would actually be over just a little bit. I didn't actually get it on that because this is where y would be 1, so it would be here. So for the distance formula, remember it is based off of the Pythagorean theorem. The square root of -4 minus 5 quantity squared plus -1 minus 3 quantity squared. Okay, -4 minus 5 is -9, so this is the square root of -9 squared, quantity squared, plus -1 plus minus 3 more is -4 quantity squared. What's the square root of? (97). 97 is a prime number. So that's where we would stop if they wanted the exact length. However, it is approximately. .8488, so that would be approximately 94.85. Okay, now let's look at segments. What characteristics do line segments have? Well, the distance between any 2 points is the blank of the what of the segment that would connect the 2 points. Well, think of length. Length is that distance. So the distance between 2 points is the length of the shortest line segment that would connect the 2 points. So you want the least amount of distance between the two of them, the shortest line segment, the length that will be the length of the distance between those 2 points. Points are blank if they lie on the same line. The word actually has line in it. They are collinear. It's got line in it right there, if they lie on the same line. Lines are what if they land on the same plane. What did we do last with the points? Points, collinear, same line. Lines, what? Same plane. If you said coplanar, you would be correct. It kind of has plane in it, but they used, because they've done the AR on the end, they've taken that last E off. What word means that they are exactly the same shape and size? Begins with a C. If you said congruent, you would be correct. Now, as mathematicians, we do not like to write a lot, so we come up with all these symbols. The symbol for congruent is that equal sign with the similar sign up above. Same shape, same size. They've just put it all together in one symbol. And this brings us to the angle addition postulate. Assume A, B, and C are collinear points and B lies in between A and C. Then the length of AB plus the length of BC is equal to the total length, which is AC. So this is the picture right here. And this should be down here. It should say find EC. I didn't get that corrected, so I'll have to correct that on my template. So let's look at the first one. The whole thing is 13. 1 plus some number gives me 13. Subtract 1 from both sides, x is equal to 12. So the segment ST is equal to 12 units. We don't know what units they're in, so we just leave it 12 and we put a U for unit. Okay, what about the next one? Take a minute and look. What do you know? And how will you use that? So if you're going to look and think logically, I know that from here to here is 30. But the whole thing is 49. So this piece and this piece, those are in the same position. So I would take 49 minus 30, and I would get 19. Why is that important? This piece is 19 units. Now, EC is the total of ED plus DC. That's what we're looking for. So to find the total, (19 plus 16), if it was 20 plus 16, it would be 36. It's one less, so this is 35. Once again, we use units because we're not sure what units we're in, whether it's centimeters, meters, miles, whatever. Could we find BC? Well, yes, we could, because this is 35, the whole thing is 49. (49 minus 35 will give me 14. And that would be units again. And we found all the missing pieces. If you're still struggling with the idea, please back up the video and watch it again. Okay, I'm going to take a little bit of a pause here and see if you can figure out how to find KL. Take a minute and look at the diagram. What do you notice, and how would you set up the equation? If this is my unknown, I know that these three pieces add up to the whole. So 9 plus 11 plus x is equal to 26. 9 plus 11 is 20. 20 plus x is equal to 26. At this point, I would hope you would be able to know what x is. If not, remember how we solve? Put the line through here, subtract 20 from both sides. X is equal to 6. So this piece here is 6. And that would be units. We don't know what units it's in. Okay, I'm going to take a brief pause here. I want you to see if you can set the equation up for the next one. The three pieces are the same as the whole. So I know that 13 plus 6 plus 2x minus 18 is equal to 4x minus 29. All I'm doing is setting up my equation. Now, the next step is to simplify both sides. So I've got 13 plus 6 is 19. 19 minus 18 is 1. So this becomes 2x plus 1 is equal to 4x minus 21. Now this is a two-step equation. I'm going to subtract 2x from both sides because 2x is smaller than 4x. 1 is equal to 2x minus 21. 4x minus 2x is 2x. Bring the minus 21 down. Actually, it's a three-step equation. My bad. Okay, now what? Move the numbers to the same side. I'll add 21 to both sides. (22) is equal to 2x. Now, last step, divide by 2. and x is equal to 11. And once again, that would be units because we don't know what units we're working in. So 2 times 11 is 22. 22 minus 18 is so we've done 4 different examples. Now you have one that you're going to do the diagram and solve. What does it look like? Find AC if AB is equal to 16 and BC is equal to 12. Draw the diagram and solve. If you're not done, please pause the video and finish the diagram. If you are done, check your answer. As I'm looking at this, I know that AC has got to be the outside pieces because B is going to be in the middle somewhere. We know that AB is 16, BC is 12. So 16 plus 12 is equal to 28, and that will be units. So the length of AC is 28 units. Okay, so we've done a lot of the math. Geometry is also about diagrams and drawings and constructions. So if we're looking at construct the bisector for this segment, what is a bisector? Bi means how many pieces? 2. Sector means sections. So the bisector will split the segment in half. So it will cut it on the midpoint. So remember that midpoint. So how in the world would you do that? You're not going to use a ruler. We're going to use our compass. So how could we do that? How could we make sure that everything was equidistant? Equidistant means the same distance. How could we do that? Okay, remember the way we do this, because when we do the angle bisectors, we will use the same idea. The first thing you're going to do is to make sure your compass is over half the length of that line segment. I'm going to tighten it down. Does it matter how long it is? No, as long as it is greater than half the length. So putting my spot here, I'm going to do an arc up above, and I'm going to come down below and do the same arc. Now I know those arcs are the same distance from that end point. Let's go to the other end point, and I'm going to make a second arc and make sure they intersect. I didn't quite get this one intersected, so I'm going to have to start here and go down. Because those arcs are the same distance from the opposite sides, we know they are equidistant from the endpoints. Because they are equidistant from the endpoints, anything I draw that connects these two, somebody put this together wrong. Anything that is equidistant from the two endpoints is going to be equidistant all the way up and down this line. So this is the bisector. Now let's think a little bit harder. How many degrees are in a line? 180 degrees in a line. A line is also called a straight angle. Now you remember how I told you everything was equidistant and it goes right down the middle? Okay, if this is 180 degrees and this goes straight down the middle, how many degrees are each of these angles? If you said 90 degrees, you would be correct. Those are 90 degrees angles. So, when you get ready to construct bisectors, everything has to be equidistant, the same distant, from the two endpoints or from the two sides. How do you know you're successful? You know you're successful when you can perform segment addition and construct those segment bisectors. They're actually perpendicular segment bisectors. So, segment addition, and then bisector. You have to, bisector means to cut into half equally, make both halves the same. Both halves will be congruent.